In this section, we will continue the analog signal debugging. Now that we have saved the program, we will return to SIMPL Debugger and refresh the signals. We can see the new list of watched signals, and we will clear the trace. We will begin by stimulating a button press in the select activity. Stimulate the select DocCam signal with a press. In the trace, we see that select DocCam went high. The source preview video signal got a value of 1D. In SIMPL, this would be the analog initialize assigning the value. That signal will also send that value to the DM-MD6x4 video switcher on the preview output, video output 1. We also saw sources to video enter get a value of 2D. In SIMPL, that would be the ASUM calculating a new sum because one of its inputs changed. That sum in turn triggers the serial analog one-shot to pulse the video enter on the video switcher. Then we see the initial press go low and the pulse completes. Next, we want to send the preview source to the audience source. We will manually stimulate the Send to Audience button press. That press triggered the analog buffer to open and pass the preview source to the audience source. That, in turn, sends the audience source route to the switcher. The preview source was previously assigned from the analog initialize. Then, the analog buffer was triggered, allowing the preview source to pass to the audience source. We then see the ASUM sees a change in one of its inputs, so it recalculates, and that in turn triggers the video enter pulse with the serial analog one-shot. The audience is now seeing the DocCam. We can see that the analog signals are holding their values. What if we wanted to change one of the values? We can send a value to any of these analog signals. For example, we want to send the value of the laptop input to the source audience video selection signal. We begin by clicking on the signal name in the signal tree window. Notice how the stimulus section has changed to an entry field with a send button. We can enter a value of 2D in the field and click Send. The 2D represents the laptop input as shown in the analog initialize in SIMPL Windows. There is the 2D sent from Debugger to the signal. We also notice that the program saw the change and reacted. Since the audience source changed, the ASUM noticed that and recalculated a new sum. That triggered the serial analog one-shot to pulse the video enter on the switcher. The audience can now see the laptop input. We can do the same thing to preview source, and we can see the change as well. We can set the value of any of the analog signals using the stimulus section. We will clear the trace and go back to SIMPL Windows, and clear the watch on the video subsystem. Open the volume subsystem. The volume is a fairly complex logic solution. We have an analog increment that is triggered by the volume button smart object. We have a mute toggle and mute cancel OR symbol. Then we also have volume presets with feedback. Set a watch on everything in the volume subsystem and save. In SIMPL Debugger, we see a new watch signals folder. Walking through the simple code, we see that the button presses trigger the analog increment to raise or lower the volume level. The volume level goes to the X panel to drive the volume gauge. If we go back to the X panel and trigger volume up, we see the gauge is rising. Back in Debugger, we can see what has happened with the signals. We pressed the volume up, and the volume changed. Because we held the volume up, we see each time the volume increased until we released the volume up. We can also see where the volume mute reset was triggered and where it went low. We see in SIMPL where the volume up hits the analog increment as well as the OR that resets the mute toggle. In Debugger, we see the values of the volume change the entire time the volume level was ramping. We can click on the volume level and manually change the value using the stimulus. Before we do, it is important to know that we can change the default format used to display the analog signals. From the Debugging Settings drop-down menu, we see that the default analog format is set to unsigned. If we change that to %, we can see the analog signals are showing as percentages in the trace window. We can change the default display format to hex. Note, we are only changing the way the signal is displayed. We will set the value back to %. If we go to the stimulus and enter 50% and send, we can see the volume level has changed to 50%. We can set the volume to 100%. If we change the default display format back to unsigned, and we are not sure of the decimal value of 50%, we can just enter 50% in the stimulus, and the calculation is done for us. The value entered as a stimulus must be valid for an analog signal, 0% to 100% or 0 to 65535. We can also double-click on the volume level signal in the signal tree. The detail window will show us all of the transitions of the volume level signal. You also have a stimulus section that allows you to change the value. You can change the display format here too. What does the signal look like in hex? Notice the display format is changed in the window and the trace window. We will set 50% volume and verify that the X panel has been updated. If we trigger a preset in Debugger, here is what it looks like. The analog preset symbol will cause the volume level signal to ramp to the value set in the preset, and we can see this ramping process in Debugger. We can see that the preset stopped at 80%, and the gauge on the X panel shows this too. All of the presets behave the same way. This concludes the analog signal debugging video series. Clear the trace and clear the watches in SIMPL windows.